I'd like to show you an example problem of how to solve a simple team-related problem in Excel. So let's get started. We'll get started once I figure out that I need to remember to share my screen. Ooh, made it. Sorry about that. And then now we'll get started. So what's our objective of this video? One is let's do an example of working. We're going to imagine that we're working on a team of people. It might be a team of engineers, but could also be folks from other disciplines as well. Going to be a start to finish example. I will be blazing through some details, so it's my hope that I can create some additional short videos to amplify on some of the details. But also it's my hope that you may have had some exposure to Excel already and you're interested in maybe seeing how would I go through solving a pretty understandable problem from start to finish, and what should it look like? So here we go. And so here's the example problem. Let's imagine I'm working on a small team of people. I don't know, small team of people, and our task is that we're in the design phase for a new toaster oven. And so we're designing various aspects of this toaster oven for our employer, for manufacturing. Okay. And one thing that we're working on is we're working on the design of the quartz heating element rod, like you'd see in this existing toaster oven. So it's a plain old cylindrical rod that's heated up, and that's what's doing the heating in the toaster oven. So let's go through and create from scratch an Excel tool to share with all the team members and anybody else that's interested, which can determine for any rod length and diameter. So the user, you or anybody else, could specify the diameter of the rod, the length of the rod, and you're going to create a tool that automatically computes the volume of the rod and the surface area of the rod. Now, of course, you can imagine the application here. If you're an engineer designing a toaster oven, you're using electric power to heat up this quartz rod, and certainly the amount of heat that will be admitted into the oven is going to be a function of the volume of the rod and the surface area of the rod, because you're either taking or will have taken or are going to take the heat transfer class, and then you'll get some familiarity of why is the volume and surface area of the rod important. Okay, so let's plan our work first. So before we get into Excel, before we bring Excel up, what were we going to do? Let's start with a sketch. Let's set up our basic governing equations. We can probably do this in our heads. We'll do this on a slide. Then, so that's, of course, very important before you even get started in Excel, is know what am I going to do? What's my mathematical governing equation for this little project? Then we'll plan the Excel file. We want to keep in mind ourselves and our team members in mind. They're going to be our customers. So those are our information customers. We want to do the best we can to keep it simple. Our objective for our Excel file is to make it stand alone, make it explain itself, so you don't have to tag along with the Excel file and explain to somebody else how to work your file. Okay. Then we'll create the Excel file, we'll save our work, and then we'll check the work. Okay, so anyway, let's quickly see. Let's set up our governing equations and a sketch. And so, at least in PowerPoint, I have drawn a sketch. You can also do this in Excel, but that'll be time for another video. But here's a little picture of my toaster oven. Here is a sketch of a cylindrical rod, diameter little d, length L. Okay, and our job is to calculate the volume of the rod and the surface area of the rod. Do you see how you do this? I hope so. Well, let's see. One sort of intermediate thing would be, what's the cross-sectional area of the rod? And I'm going to call that A sub X in my setup. Well, that's just going to be the area of a circle, isn't it? Pi over 4d squared. That's the area of a circle. And once you've got that, then it's child's play to get the volume of the rod. The volume is simply going to be the cross-sectional area times the length of the rod, kind of like cubic centimeters, cubic millimeters, okay? Surface area of the rod. Well, let's see. If I get the circumference of the rod times the length, that's going to be the surface area of the rod in, let's say, square millimeters or square centimeters or square meters. The surface area of the rod, of course, will be pi dl. So there's our setup. But I hope that you can imagine that this could be an assignment that you take on as part of a team in a design. Okay, and so let's see, I've got to move my Zoom menu here, right? Create the Excel file, and I've got a couple of little reminders for myself and for you all too. What are the basic things? We're going to open Excel. We're going to immediately put down a title, okay? We're going to start with a sketch or some kind of visual sketch. We're going to work down the page to implement the solution. During that, we're going to try to think about the customer. That's going to be you, the author, and others. Why are you a customer of yourself? Because you're going to create this kind of cool file. You're going to save it, but you may have to go back and revisit this file 6 months, 9 months, a year later. And I can assure you that unless you document your work well, you'll be your own customer. But unless you document your work well, you're going to totally forget what you did on this file. And of course, we're going to save our work. So here is my prompt to go live. And so I'm going to try to go live. Okay, whoops, there's Jay's toolbox. Okay, so I'm going to bring up Excel, and here is our blank slate Excel. I just click the Excel icon, and this is what I've got. And look, right now there's no rows and columns. Gosh, what do I do? I'm going to click on, I've got to move my Zoom menu. Excuse me a second. I'm going to click on File. Okay, and then New. I'm going to start a new file. Okay, I'm still prompted for something, and I look around. Oh, here's create a new blank workbook. That's what I want. We don't want to start with a template. We're smart enough to go from scratch, okay, and make it look good. Create. Okay, so here we go. We're now in the kind of Excel creating environment. We've got rows and columns. See, I'm clicking in different cells, right? So columns A through triple Z, okay? Rows 1 through 1,000,000, okay? So nearly unlimited size of a sheet. And now let's look at the bottom here of this page. This default, this blank workbook, blank file. It says sheet 1, sheet 2, sheet 3. Those are terrible names for sheets, and we're going to clean that up in a minute, okay? Let's see, the first thing, oh, and I've got to move my Zoom menu again. Notice here how right now the name of this file is book 4. That's a terrible name for a file, right? Book 4, horrible, has nothing. Maybe the first thing we do before we even start is name our file. So let's do File, and let's save as, okay? And I'm going to create a place on my PC called, I've got a folder called Live Demo, and what should we call this file? Let's call it Quartz Rod Calcs. Quartz, I'm not going to make a space, Rod Calcs. Okay, so that's our file name, and I'm going to hit save. Okay, so sure enough, now we've named our file. That's a good start. So we've got nothing in it, but we've named our file. Okay. Next thing to do, let's go to cell A1 and let's create a title. And I'm cheating a little bit. I've sort of worked on this before. And so I want to be sure that I get things complete. So let's call this volume. I'm just typing out words in cell A1. This is just words, text, volume, and surface area of a rod. Okay. And now it's the default font, okay? I'm going to click, I'd like to make this bold and bigger than the default. So I'm going to click on Home, okay? See, up in the top. And now I've got control of the font and the bold and stuff like that. So I'm going to click in cell A1. I'm going to click bold. And right now it's size 10 font. I'm going to click this enlarge the font button. Okay. This may be some customization that you'll have to dig in and customize, but I believe this is just about the default look of Excel. All right, so I'm going to make it bigger. I could either drop down the font size and go to 12 or make font size bigger. Okay, so there's 12. So that's pretty good. Volume and surface area, right. Next thing, so we're getting there. Just bear with me. The next thing we need to do is, it's a courtesy to yourself and others by putting in the Excel file what's the name of the file. So I'm just going to type out in regular font file, Quartz Rod Calcs, calcs.xlsx. That's the default, that's the file type of a plain Excel file. I'm going to hit a couple of spaces and I'm going to say what date it is. Right now it's 5/9/2024 by me. And so I'm going to put my initials because I'm going to claim, I'm going to make it clear who's doing the work here so that if others on the team need to ask some questions, at least they'll know who to go to, who to call without trying to do detective work. All right. So we've titled and added stuff. Next is kind of write out a real quick sentence about what does this file do? Determine the volume and surface area of a cylindrical rod with known diameter and length. Okay, so you can be as wordy as you want. You can see that. So I've just gone into cell A4. I've started typing. You don't have to fit the words into that cell. It just bleeds over into the next cells. Okay. The next thing to do, I think, when you're working with others, when you're trying to create a little tool, even for yourself, is start with a sketch. And so what I've got in mind is to insert a picture of a toaster oven and also insert a picture of that sketch that I created over in PowerPoint. I saved it as an image. So let's go to insert, go look up higher, insert a picture. Okay. And I've got my correct folder, my images folder, and I'm going to click on my toaster oven picture and insert. And that's too big. So what I'm going to do is grab a corner and shrink it down to make it a little more palatable. Okay, that looks pretty good. All right. Next thing I want to do is that sketch of the cylindrical rod. So let's go to insert, picture. I'm on my PC, and so I'm at the right folder. I know where I've got my sketch all done. And I've inserted it. Now that's starting to look pretty good there. Okay, so far so good. Now you can create this sketch with the drawing tools in Excel, but just to save time, I went ahead and created that sketch alone. Hopefully a video for that later. All right, so we're getting there. We haven't created any mathematical formulas in Excel yet, but we're getting there. Let's see, before we create formulas, what do we need to do? We need to enter the known data. Well, we don't know what D is. We don't know what L is. But team members are going to suggest what those values should be. And so I'm going to come up, first thing is let's go to cell B16, column B, and type out what number we're going to enter in text. The diameter, and let's have some units, millimeters, and let's call it rod diameter. So the next thing we'll do is we're going to go to cell A16, okay, and let's just type, let's say we've got 8 millimeters. We can change it to whatever we want, but let's just start with the number 8. Okay, next thing, how about L? L, also in millimeters. We'll call that rod length. You see what I'm doing is not only am I putting numbers in, but I'm defining what they are with units. So let's say 75 millimeters. Okay, so that could be a good starting point for our team in designing our quartz heating element rod. Okay. Now, notice here, it doesn't jump out at you. Oh, I know. Let me continue on, and then I'm going to backtrack a little bit. We're ready to do some math, aren't we? We're ready to calculate a sub x. And what will the units of a sub x be? Millimeters, and I'm a little exponent, square millimeters. And I'm going to go ahead and say cross-sectional area. And in fact, you probably don't exactly need to, but for right now, let's keep typing. What is it? What's the formula for that? Just in text, pi over 4 d squared, d caret 2, pi over 4 d squared. Now that's not doing any math. That's just text. So we're going to come over here to cell A19, and we're going to type in our formula. So when we type a formula in Excel, you always start with, just strike the equals key, strike equals. So now we're typing a formula, equals pi. So Excel has got this really cool built-in value of pi. We just type in pi with open and close parentheses. So it's going to put in 3.14159 for you, pi. Okay, let's see, pi over 4 times, now, d squared. So you don't type d caret 2. What you're going to do is you're going to come up to cell A16 and click cell A16. You click it. So you put in the value for cell A16, and then you're going to square it. So caret 2. So there we go. Does that make sense? Does it make sense that the cross-sectional area of 8 millimeters squared is around 50? Let's see. Pi over 4, that's 3/4, times 8 squared, 3/4 of 64. That makes sense. Looking good. Okay, let's keep going. The volume. Let's see, what's the units of volume? Millimeters cubed, cubic millimeters. That's the volume. Okay. And let's see, just for completeness, let's see, that's A sub x, cross-sectional area, times L. It didn't take much effort to type that out, did it? So just do it. All right. Okay, so we're ready for another formula in cell A20. Start a formula, equals. I've got to multiply two things together, A sub x and L. Well, now that I've documented my work, oh, I see A sub x at cell A19. So I'm going to click cell A19, mathematical multiply times star L. Well, here's L. I'm going to click cell A17, okay, and hit enter. I don't think I said that the first time, my first formula. Hit enter. Great. Okay, cool. Okay, so there's the volume. All right. And let's see. Now, let's skip a line. Let's skip a row, because do you see how those two were sort of related? Those two calculations were related. Let's skip a row. You don't have to go row by row by row. Skip a row and say, what are we going to do next? A surface. We'll call it a surface. And let's see, what are the units of that going to be? Millimeters squared. Okay. And let's see, what will that be? Pi times d, there's the circumference, times L. All that's just text, all right? And so let's see, third formula. We're going to go to cell A22, equals pi. Well, I'm going to type out pi, open and close parentheses, times d. Now let's see, here's d, because you see, you helped yourself by labeling the cell. So I'm going to click cell A16 and L times, here's L. It's in A17, okay? There's my formula, hit enter. Boom, okay. Well, lo and behold, I'm sort of done with all the calculations. That's kind of cool. Let's do some cleanup work. And so this is consistent with what I do day in and day out, both when in manufacturing and teamwork, and also working with students and trying to give them some homework tips. First thing is, let's make clear what the user puts in. So do you see that these two cells are manually, I call fat-fingered, numerical inputs. They're not formulas, they're just numbers. I'm going to light up both of those cells, and I'm going to go to my bordering tool, and I'm going to click the bordering tool. And now look what I've done. Do you see how I've created borders around there? Okay. I'm going to do the same thing for my numerical work. Borders and a border. And do you see visually how it kind of makes it stand out from the spreadsheet? Okay. That's kind of cool. My input numbers. One of my coworkers with a mechanical engineering degree from UVA taught me this really neat trick. He said, look, whenever I fat finger in a number, whenever I manually enter a number, I color those cells yellow to remind myself that those are input values. I don't do anything with the color of my formulas. Notice here, I just clicked on cell A19, and here's your formula for A19. This little formula bar up here enables you to check your work. Check your work. So is this the cross-sectional area? Pi over 4 times A16 diameter squared. Yeah, cool. Okay. Coloring, we leave those clear colored to signal to ourselves that that's a formula in Excel. Okay. Part of the governing equation. Here's another thing that I've noticed. Notice here, the number of significant figures is dramatic overkill. Okay. And so another thing is the decimal points don't line up. In my work, I like for decimal points to line up. So I'm going to light up this whole range. And I'm going to come up here in my home menu bar, and I'm going to drop down the number formatting tool. I just dropped down the number formatting tool, and I'm going to click number. Okay, so it's a number, a numerical value, and it allows you to control the number of decimal places to the right of the decimal point. And so just for this demo, let's click 3 decimal places and OK. And now all these line up. Well, let's say, man, you could say that's way too many significant figures for our design team. Nobody's going to come up with thousandths of a millimeter. So you could say, okay, there's a good argument for that. Let's go back to number formatting tool, number, instead of 3, let's make it 2. Okay, you see how the decimal points line up? That's kind of good looking, okay? And I've got a little better, maybe that's for this particular application, that's a little better numerical format. Okay. Wow. Let me check my little cheat sheet where I've already went and remind myself, what else do I need to do? Oh, one thing I need to do is save my file. I've made a bunch of really good changes. I'm going to come up, I can either go File, Save, or I've sort of customized this very top row, and here's File, Save. There's a single icon, and I've saved it. So I've saved quartzrodcalcs.xls to my PC in a folder that I know exactly where it is, and that's critical. Okay, don't just save it to my documents. Save it to a folder that relates to your project work or however you organize your work. Okay, another thing to look at that really it helps define people as effective people or people that just use the default of stuff. Let's look down at the bottom left of the screen. Notice here when we started from scratch, we've got 3 sheets, sheet 1, sheet 2, and sheet 3. What does sheet 2 look like? It's a blank slate, okay? You don't really need sheet 2 in your file. So I'm going to right click on this tab, sheet 2, right click on it, and I'm going to delete the file. It's empty. It's gone. Same for sheet 3, don't need it. Okay, so now I'm down to sheet 1. As you get better and better at this and your projects increase in complexity, you're going to want to start using multiple tabs in a single Excel file. That is an extremely powerful tool in Excel. So it makes sense to title your tabs a lot better than sheet 1. Sheet 1 is meaningless. It means nothing. I'm going to right click on sheet 1 and rename sheet 1. And let's see, we got to come up with a good name for it. And let's call it Rod Calcs. And I typically do not put spaces between my words. So I make little capitalizing. I think in Google, they call that camel titling. Those camels for the little humps with the capital letters. Rod Calcs. And then I'm going to click away from it. I'm just going to click on any cell. And now we've retitled our tab Rod Calcs from sheet 1. All right, great. And so I'm going to hit File Save. And now do you see that once I can close out of Excel? So I possess the file. I've created a little tool, pretty simple, a little mathematics. It's going to help the team members quickly be able to, as they do their design and calculations and thinking about how would we design this new toaster oven, it gives them a tool to quickly look at the geometry of what different size and length rods would be and how that'll fit in their design. So you can send this file to folks on your team. They can use it as a tool. You can use it as a tool. And that's basically it. Now let's see. I need to go back to PowerPoint to finish up the presentation. See if I can. I'm going to close out my file. So instead, I'm not going to close out Excel in the top right. I'm going to go down below. The little X is close this file in Excel, but leave Excel open. All right. So now we're back to just gray. I'm going to minimize Excel. Let me do one thing at a time. I'm going to bring back PowerPoint back again. We've gone live. We've created our tool. We have saved our work, thank goodness. And now let's check our work. So just to try to hit the highlights, notice here how we've saved our file to a file name. In my slide prep, I called it SimpleExample01 instead of Rod Calculations. Okay. Let's see. Here's my retitled tab name down here. Looks good. Okay. Here's my yellow cells that indicates to myself, maybe a year later and others, that this is where you enter numbers. And then clear cells, these are Excel formulas that use the input data to give you the results you desire. And it's kind of cleaned up. The little overkill on my screenshot, I'd say that's probably a little too many significant figures, maybe 2 significant figures or 2 points to the right of the decimal, probably a little more appropriate here. And so let's see, does it do the job? I think so. I think it, how does it look? I think it looks pretty. It started with a sketch, so it's very clear what are these variables? What is D? What is L? The sketch really shows that, okay? Consider getting feedback from others. So once you send this Excel file to others on your team, you might consider asking them, have you tried that tool? Did it work for you? Did it do you any good? Okay. Is there anything different that you would like me to do as a team member that might make it easier for you to use this tool? Now, the chances are that your team members are going to have more ideas, and this file might grow and grow. You would generate ideas where you get a little more and more fancy, more sophisticated. Maybe you get more into the engineering of the heat transfer from the rod, but it's a great place to start. And this is a way to use Excel in 2 ways. One is it's a problem-solving tool, so it's you're able to apply mathematical fundamentals. A lot of folks call them formulas, mathematical fundamentals to solve the problem at hand, but also you're going to use it as a communication tool for others on your team and beyond. And the combination of those two leads to your effectiveness. Okay. One thing, this is the last slide, and but one thing that I've experienced in my work career, in particular with peers or supervisors, and they're going to come back when I share my work, they say, I would have done that differently. I would have done that differently. There's no reason to get insulted by that. Okay. There's nothing wrong with doing something in Excel differently or even using a different problem solving platform. But here's the things that you would test when someone says, I would have done that differently, almost to get you straightened out. Don't worry about that, but ask yourself, the person may be doing it differently. You want to be, are the basic governing equations the same? Okay. Does that different method solve the problem correctly? Okay. Is that different way simple to understand? Is that different way that the person suggested, is that method well documented? Can the work serve as a generic tool? Can others use your work and leverage that work to go further with it? Okay. In other words, is that other suggested way effective? And so that's a way to respectfully reply to someone who said, in an indignant way, perhaps, I would have done that differently, or that's not the right way to do it. Sometimes you got to be careful about that. You want to listen. You may have made a mathematical error, and then you want to work collaboratively to understand how do we get that straightened out. Absolutely. But the old, I would have done that differently, that is a tried and true feedback from other folks when you're sharing your work with them. So that's that. Okay. I hope that this little simple example problem illustrates to you how would I create an Excel file start to finish. I glossed over and threw at you a lot of details if you have never used Excel before. If you have used Excel, then you may have been able to pick up on some of those subtle features. It's my hope that I can go and create little videos to pick off those little details and address those one by one. So I hope you've gotten something of value out of this, and good luck with you as you get better and better at using Excel as an effective problem-solving tool.